If you use the information that we learned on the previous page, you should be able to answer all of this on your own, but I'm just going to double check and get you started here. So first of all, it says the discriminant is the part of the quadratic formula under the square root symbol, and then the discriminant is equal to b squared minus 4ac. If that discriminant is bigger than 0, you should have that there are two solutions. If it's equal to 0, there's one solution, and if it's less than 0, there are no solutions, or 0 solutions. In any case, the x-coordinate of the vertex can always be determined by x equals negative b divided by 2a. So, determine how many x-intercepts each parabola has without actually solving for the x-intercepts. What you could do is calculate the value of the discriminant, figure out what b squared minus 4ac is equal to, and if it's going to be greater than 0, there's two x-intercepts. If it's equal to 0, there's one, and if it's less than 0, then there's none. So for the first, the b value is negative 5. We're going to take negative 5 and square it. Minus 4 times the 3 times the 7. That'll be 25. Take away, 12 times 7 is going to be bigger than 25, so I know this one will be less than 0. It's going to be a negative answer. You could actually calculate that. 12 times 7, I should know what that is, but it's late, and it's 84. And then if I take that 84, make it negative and add 25 to it, we get negative 59. So yes, it is definitely less than 0. It's going to be a no solution, or no x-intercepts in this case. Okay, so try that with part B and part C. Part D is a little different. Part D is not in its standard form. So for part D, I want you to think about what format that is written in, what it's telling you, and how you can decide how many x-intercepts there will be without actually solving for them. And for me, what I would do is decide what it tells me, and then I'd do a little sketch, because as you may have heard me say, I'm a visual learner. So for me, if I can sketch it out, I can see what's going on. When you get down to the next example down here, you're determining the x-coordinate of the vertex. You're just using that x equals negative b, all divided by 2a. So it should be negative 5, divided by 2 times 3, which then becomes positive 5 divided by 6, or 5/6. There's your x-coordinate of your vertex. So you can do B and C. Put the video on pause, try it out. You can check your solutions when you're done. Okay, if you check your answers here, part B for the example with deciding how many x-intercepts had 2 x-intercepts. Part C had exactly 1 x-intercept. Part D, I figured out the vertex and then it was opening down, so I did a little sketch, estimated where 5, negative 1 would go, and had it open down. Clearly it's not going to cross the x-axis, so it has no x-intercepts. And then for my x-coordinates of the vertex, I had a positive 5/6, a negative 2 for part B, and for part C, the x-coordinate of the vertex is at negative 3. Okay, on the next page it says, solving some problems using the discriminant, find the value of k that makes the following quadratic a perfect square. So if something is a perfect square, what happens is when you write its factors, the factor is one factor but to the exponent of 2. So what that means is that there would be one x-intercept for that. So if I want to do factor this, or use the quadratic formula, or the discriminant piece of the quadratic formula to decide that, I know there can only be one x-intercept, which then tells me that the b squared minus 4ac has to equal 0. Now we could also use our other method. If it didn't say I needed to use the discriminant, I know that I really could take half of negative 5/2, so half of that, divide by 2, and then I could square that answer, and that also would solve for my value of k. So I know that my b squared minus 4ac has to equal 0 here. So I'm going to use the discriminant. So that means my negative 5 over 2, if I square that and take away 4 times my a, which is 1, times my c, which is k, I know that has to equal 0. So 5 over 2 squared, negative 5 times negative 5 would be 25. 4 times 4, or sorry, 2 times 2 would be a 4. And then this would equal minus 4k. 4 times 1 times k is 4k. That has to equal 0. I'm just going to slide up here. That tells me then that 25 over 4 is equal to 4k, because I'm adding 4k to both sides. And then I'm going to divide both sides by 4. I'm going to divide this by 4 so that I can get k by itself. And if I have 25 quarters, dividing by 4, that's really 4 over 1. That's going to times by 1 quarter. That'll equal k, and we get 25 over 16 would be my k value. Okay, so if I took this and divided it by 2 like I had said, we can just double check that. Dividing by 2 is the same thing as multiplying by 1/2, and then we want to square that value. That's going to give me a negative 5 over 4, which if I square that, that's a positive 25 over 16. So either way would work, but I just showed you how you can use the discriminant to do it as well as the other way. Number 2, find any value of k so that the quadratic below has 2 different real solutions. Check your answer by substituting it into the equation and then solving it to show 2 solutions. So to get 2 solutions, I know that my discriminant, my b squared minus 4ac, would have to be greater than 0. So my b is my 3 squared minus 4 times a, which is 1, times c, which is minus 2k. That has to be greater than 0. All right, so that gives me 9. Minus 4 times 1 times minus 2k would be a plus 8k. That has to be greater than 0. Now this gets a little bit tricky in terms of how to solve for this. There is a rule with inequalities. They work almost the same as equations. The only time we have to worry is if we multiply or divide by a negative number over an inequality, we end up having to invert our inequality to the other side. So if it was greater than, it would become a less than. That's something that we focus more on in grade 11. So my example here, I'm just subtracting 9 from both sides. It's not going to change my inequality. My 8k would have to be greater than negative 9. I'm dividing by positive 8 next. As long as I pick a k value that's greater than negative 9 over 8, I am going to get 2 different real solutions, 2 different x-intercepts for that. So any value, as long as you pick any value bigger, and so I'll leave that up to you, any value that's larger than negative 9 over 8 will give 2 solutions. We'll give 2 solutions. Okay, you can pick a value. So like negative 1 is larger than negative 9/8, negative 0.5, 0, 1, 2, 3, 4, any number bigger than negative 9/8. All right, the last example here. Find all possible values of k so the quadratic below has 1 unique real solution. Check your answers by substituting them into the equation and then solving it to show 1 solution for each value of k. All right, so find all possible values so it has 1 unique real solution. So 1 solution means that my b squared minus 4ac has to equal 0. So this is kind of a problem-solving question because we haven't done this before. So I'm going to let you think about this one. I'll do up my answer, and then when you get yours done, you can check with me. I'm not going to put it on the video because I really want you to see what you can do with this and where you end up. All right, good luck.